Morning, everybody. Morning. Morning.
Good morning, sir.
All right, good. Yeah, I had a little problem signing in this morning, but we're good now. We're good. We're good. All right. All right, hold on. All right, we're gonna start. All right, so we have everybody's here. We have Jenny. All right, who's missing? All right, so let me just remind everybody that we're ready. All right. All right, so what we're gonna do now is, let me see. Good morning, Stenet. I just saw that. All right. All right, we're gonna jump on to who is missing. I'm seeing more people coming on now. We're going to start now. All right. All right, good. Morning, Eve.
Good morning, sir.
All right, good morning. All right. All right, can we see, let me share my screen now. We're gonna deal with a certain presentation now. All right, we seeing the screen?
Yes, sir. Yes, sir.
All right, very good, very good. All right, what we're gonna do today, we're gonna be working through the papers. So if you notice this question here, I would have sent it some time ago and asked us to print it so that when it's time for us to work, we actually can deal with it. Everybody has it? Everybody has it?
Yes, sir. No, sir.
Michaela, it's actually in our group. It's in the WhatsApp group. So you would have to go in there now and look at it. Other persons might have printed it and stuff like that, but it was placed in the WhatsApp group. All right. So the questions that we're gonna do, I placed them in the WhatsApp group from week before last, and then last week I post another set. So if you notice, I have 20 slides here. We're gonna try to go through the questions. But guess what? I'm also going to work on the questions here. All right. So I'll send, remember, we have the recording going. So you will be able to watch back and see what's going on. So let us look at number one. Let's look at number one. It says, if you want me to, can you read this? Is it okay? Are you seeing it? Number one here?
Yes, sir.
All right.
Yes, I'm seeing it, sir.
All right, good. So it says, what is the number at the parking space covered up by the car in the series below? So we want to know what is the missing number for this spot right here. So we have a 4, then we have a 7, then we have 12. So based on what is going on, you would notice here that there's a slight pattern. From 4 to 7, that's 3, we're adding 3. And then from 7 to 12, we add 5. And then from 12 to 19, we have 7. So it's like, if we should look at the pattern of addition, first we add a 3, then we add a 5, then we add a 7. Can everybody agree to that pattern? All right.
Yes, sir.
All right. So we added 3, then 5, then 7. So therefore, we're saying that, guess what? I would assume that the next one we're going to be adding 9. So that's the pattern. All right. So we're going to be adding 9. So 9. So the answer is that we're going to be adding 9. Agree? So 9 plus 19 would give us 28. Agree? 9 plus 19 would give us 28.
Yes, sir.
All right, very good.
Yes,
all right.
Sir.
All right, good. So 9 plus 19 give us the 28. So we would have circled, let me just pick a nice color pen. All right, I might just use red. So we'd have circled that for the answer. Good? All right. So let's go to the next one now. Next one here. It says the numbers in each diagram below, all right, follow the same rule. So we're told that there is a rule that was followed here. Use the first two diagrams to help find the missing number in the third diagram. So the missing number is right here, right? That missing spot, right? So in order to find this, we need to observe what goes on for these two. Let us figure out how did they get 9 here, all right? What did they do to get that 9? So that's the thing, all right? And that same thing, what did they do to get the 18 here? So we have to follow that idea to see what is missing here. Can anybody look and tell what it is you think? How we get the 9 here? Come on, guys.
Sir, I know the pattern.
Go.
They multiply the 2 by the 3, and then they add the 6. They multiply the 2 by the 3, which makes 6, and then they add the 3 to the 6, which makes
exactly. Exactly. So if we look on this one here, the pattern here is that we have a 2 plus 3, and that would have given us, no, 2 times 3. Let me put the regular. 2 times 3, and that would have given us 6. And then we added the other 3 at the end, and that's how they got the 9. All right. So for this one, you're seeing this is the working out. Let me just put it right beside it. For that one there. All right. That's it for that one right there. Everybody can see that right here. And then now for this one, you're seeing that we have a 3 times 5, and that gives us the 15. And then you add the 3 at the end. You add a 3 at the end, and that gives us the 18. All right. So you're seeing that for this spot here for the second one. Everybody see that? 3 times 5 plus this 3, we get 18. So therefore, it's this number, missing number, times that, then we add 3 to get the 38. Now, would you agree that in order to do this one, you probably need to work backwards? Like we want to say the 38, take away 3. And then that is going to leave us with 35. So we're going backwards. So it's like normally we would have gone this way to multiply, then we add, and it comes here. But because this is missing and we're already at the end, we could subtract the 3 and know that it was 35. Then we're going to divide that 35 by 7. So at this point, we're going to divide this 35 . Hold on. All right. Hold on. All right. So we divide the 35 by 7. And what would you get?
5.
5. So we work backwards for that one. So I'm going to put the indication that, guess what, guys? Work backwards. So when you're reading back the, when you're watching back this, then you can actually just see the little notes that we're putting here. So we're working backwards for this one, and that is how it helped us to get that idea. Can everybody attest to that?
Yes, sir.
All right, very good. So now we saw that the answer, our answer here would have been 5. So these are the questions that you're having. You know that you have the mental ability exam first, right?
Yes,
Come on, I think the mental ability is in, is that January or February? One of those.
Sir, what date?
I'm not sure. Probably
February.
You can check with your teacher at school and find out, but the mental ability is first. That's why I'm focusing on it a little bit more. All right, let's go with this question now. All right, let's read this question. It says, examine the first 2 rows. All right, remember, I know, examine the first 2 rows in the pattern below to determine the number of, to determine the number to replace the question mark. So we're going to observe what goes on here, observe what goes on here, and then we decide what comes here. What goes there, what goes here. Well, you're going to have to think though. You have to think about 0 and it turns into 0. Then you think about 1 and it turns into 1/3. And if you think about 3, what will it turn into here? There are many things that are happening, but I'm just going to put here that, you know, let me change the text to already. We want to agree that if you do whatever we're thinking of must be able to work with everything. So I'm suggesting here that we look at this. We are dividing by 3. All right, we're dividing by 3. So if you really check this out, you do realize that we have 0 turns 0. So 0 divided by 3 is a 0. And then on this one, we're checking that 1 divided by 3 is 1/3, 1/3. So 3 divided by 3, what are we going to get? We're going to get 3 over the 3, and that is equal to 1. All right, 3 over 3 is equal to 1. Therefore, this is the solution right there. How does that look? Everybody?
Yes, sir.
Yeah, man, these are patterns
Sure.
that you have to think about what happened, you know? So what gave you the clue sometimes, you know, even this here, you're seeing number 1 here, and then you're seeing it over the 3. So basically you're saying, oh, 1 was divided by 3 here. And then you try it here. 0 divided by 3 is 0. So it works for these two. So then you could try for the third one. 3 divided by 3 is 1, and the answer is there. So you have to just take your time, look at the pattern, as they say, what you have, and you move forward. All right, very good. All right, let's look to the next one. This one here. So we're supposed to look what's going on. Look carefully. We have a number of boxes here. This looks like about 16 boxes. And if you look, it's cut up into quarters to me. You could get some quarters from this. So if I should run some line through this, like if I follow that, you could see that this is in quarters. So everybody look. So this, this section here is actually a quarter. And they are saying that this represents this. And it makes sense because you could see that this is a quarter as well. Agree? The shaded is a
Yes,
quarter.
sir.
All right.
Yes, sir.
All right, good.
Yeah.
All right. So now what we want to do now is to observe this and then pick the right answer. But in observing this, you know, we're going to have to count. So let us see. This is a 16 box. Everybody agree that the entire thing is 16?
Yes, sir.
So let's count to see how many was shaded. 1, 2, 3, 4, 5, 6, 7, 8. So basically then, when we look at this, we're looking at 8 over what? 16. And 8 over 16,
half.
mighty. Yes, very good. A half. So you want to look at something that deals with a half.
Sir,
That
A.
deals with a half.
Sir, A.
A deals with a half. Excellent. So this is the answer. So it's more of observing what's going on. And this is how the mental ability exam is. This is an exam that came, you know. It's not make-up question. This is an old exam that came. All right. All right, let's go for the other questions that are there. Everybody agree that this would have been a half based on what's going on?
Yes, sir.
Yes, sir.
All right. All right, let's look at another question. All right, so we're going to, all right, this one now. This one normally poses a little bit of problem. This one here, it normally poses a little bit of problem, and you have to be very careful when you're dealing with it. All right. So I hope we can see this. So we have, let me put this. We have a chicken and a cat. Everybody say the chicken and a cat?
Yes, sir.
So when
Yes,
the,
sir.
so when the chicken and the cat,
Yes, sir.
yes, so when the chicken and the cat went on the scale, we get 8 kilograms. Then now, the chicken stayed. You realize that the chicken is still there?
Yes, sir.
Yes, sir.
All right,
Yes,
so the
sir.
chicken is still there, and then the cat came off and the dog came on. And then guess what happened? The weight changed to 16. Is there something here that we could think of right now? Because the chicken was the same, but the dog replaced the cat. All right, and the weight went up. Now, can we compare the cat and the dog? All right, can we compare the cat and the dog's weight? We want to think about that, think about that quickly. And here is the clue, because when you look at it, you're realizing that the cat, since so mighty, you would agree that since the chicken remained and the scale went up, it must have been saying something about the dog compared to the cat.
Sir, weighs more.
Yes, the dog weighs more, and not only that, we can be very specific. You actually could tell exactly how much more the dog weighs. So anybody wants to just tell me?
Sir.
Yes, sir.
Go.
12 kgs. The dog weighs 12 kgs.
No, and that's not the question, I don't know how much the dog weighs yet, but I'm saying how much more the dog weighs than the cat. How much more?
Sir, 12.
All right, look, let's discuss. Because I want you guys, remember, you're trying to figure out, look, what was the difference in the weight from A to B?
Half.
No, man. What was the difference is a number we want. Because we have numbers here. This is 8
and
and 16. What was the difference in the weight?
That one of them
Eight.
changed and
Yes, the difference in the weight was 8. Very good, class. So when the dog came on the scale, the scale went up by 8 more kilograms. True or false?
True, sir. True.
So then, can't you compare how much more the dog weighed than the cat?
Yes, sir.
How much more?
Yes.
Eight. Very good.
kilograms more.
Yes,
than
yes,
the-
and that is
than the
very
chicken.
good. So the dog weighs 8 kilograms more than the cat. So because the dog weighs 8 kilograms more than the cat now, then you'll be able to see something here. Look at this now. The dog weighs 8 kilograms more than the cat. And now we have the dog and the cat on one scale. But remember, the dog is 8 more than the cat. True or false?
True.
All right. The dog is 8 more than the cat. And now I have the dog and the cat together. And both of them weigh what?
20 kilograms.
20 kilograms.
What can you do now to know? Come on, somebody. What can you do now to know the cat or the dog's weight? Come on.
So it can multiply.
Think about it, man. Come on.
Sir, subtract.
8 more. You have 20 now. You're thinking about the number 20 and you're thinking about yours. All right. If you and I step on the scale, I weigh 8 more than you, 8 kilograms, and both of us goes to 20. All you have to do is to find a number. Find two numbers between 0 to 20, where one is 8 more than the other.
Sir.
10.
Huh?
10.
Sir, 12.
What is 12?
Sir.
Who is 12?
The dog.
All right. So if the dog is 12, you're suggesting that the cat is 4. 12 and 4 is not 20.
16.
Who is 16?
The dog.
The dog is 16. And if the dog is 8 more than the cat, you're saying that the cat is 8. 8 and 16 is not 20. You see how easily you can pick up this? Come on, guys. This is very easy. 8 more.
Dog is 14.
The dog is 14. The dog is 14. Dog equal to 14 kg. cat equal to 6 kg. That makes sense now?
Yes, sir.
Yes, sir.
So, because this is how I want you guys to reason out your stuff, man. Don't guess your answers. Never guess. Because this is how the 20 comes. See there? You could see the 20 coming now from this. And then when you add them, you get your 20 and the dog is 8 more for real. So in other words, then dog is 14, cat is 6. No, watch this, you know. If I know that the dog, if the cat, look at this, the cat is 6. So if the cat is 6 here, if the cat is, let me line them up. If the cat is 6 here, then what is the chicken? You see that?
Chicken is 2 kg, sir.
KG.
Very good, very good. That's what we're talking. So now you can see that when you start pulling up the things, you're able to actually find.
So number 22.
Sir, the dog was 4 kgs more.
In all, it's 22.
In all, it's 22. In all, it's 22. Total, wait. I'm just writing it out for you. That's when you go back on it, you could see 14 plus 6 plus 2, and that is equal to 22 kg. No guessing. No guessing. Right? So we're seeing that, hey, that's how we work out these problems, right? No guessing, because a lot of people guess, you might end up in problem. You understand? So we don't want to guess them. But you can see the logics. There are times when you have to just relax and figure out, look, compare. And there's a reason why they left the chicken right here. Because they wanted to see that it was a dog that pushed up the scale. And then you compare and say, oh, the dog pushed it up by 8. That means the dog is 8 more than the cat. Ah, now if I have the dog and the cat together and the dog is 8 more, and both of them weigh 20, one is 14, one is 6. Oh, and then I pick it up. And then I use that right here to get the chicken, which is 2. And then I put the get. So you can see the step-by-step, right? The step-by-step idea.
Yes, sir.
Yes, sir.
Very good, very good, very good. We're getting it, we're getting it, we're getting it. Remember, this is a past paper, so if you feel comfortable working, that's how you're going to feel on the exam. All right, let's go for number 26, right? It says, Sarah measured the length of her hand in centimeters. The length was between 11.5 to 11.6. All right, which of the following could have been the length of her hand? Now, we're looking for the fact that, let me write out this number for you. It was between 11.5 to 11.6. That's what they said, right? So talking about 11.5 centimeters to 11.6 centimeters, right? So the length was between that, as you could see. They want to know which one of these numbers will fall between 11.5 to 11.6. So you need to just pick which one of these numbers you think fall between that.
So I think 11.5.
11.51.
5-1.
Exactly. 11.51. Very good. So these are the questions that they're giving, you know. 11.51. So after 11.5, 11.51, 11.52, 11.53, 11.54, 11.55, 11.56, 11.57, 11.58, 11.59, and then 11.6. So you can see 11.51 was between that for real. Everybody agree to that?
Yes, sir.
Yes, sir.
All right, very good. Let's go to number 27. I don't know if this one is clear enough, but some of you might have had your own printing. I don't know if you printed it or if you're looking at it soft copy. Are you able to see these good?
No.
Yes, sir. I didn't.
You're able to. Yeah.
Yes, sir.
All right. Let me see if I can quickly help to put in some numbers here. All right. This first one here is a what? $10. This one, is this $10 right there?
Yes, sir.
Yes, sir. That's $10.
All right. So what I want to do, I just want to help us to just do that quickly, because in the exam it will be very clear for everybody to see. Not true.
Yes, sir.
So we're just trying to make it clear for everybody. So that is $10 again, right? There's another $10 there.
Yes, sir.
Yes,
All
sir.
And then this one beside it is what? $5, right?
Two $5.
All right, good. So let me put $5 in there, Mighty. Give me a second. We just want to make sure that we do it proper so everybody can see before we do the question. We don't want anybody to get it wrong unnecessarily. And then there's another $5 you're saying, Mighty, right there. All
Yes,
right.
sir.
All right. And then it looks like this is a $20 now, not true?
$20.
That's
Yes,
a 20.
Yes, sir.
All right. So 20
And then a 10.
and then a 10. So I can easily make the duplicate now. So I'm fixing it for the class. And then a
And
5.
Then a
Yeah.
5. Then a
3
5.
5s, sir.
3 5s. All right.
Yes,
So, all right. So that's good when you can do that. This is a nice software, not true?
Yes, sir.
Sir.
Yes, sir.
This is what you use at school?
No, sir.
No, sir.
You don't use Jamboard?
Yes, sir. Yes, sir.
Yes, sir.
A Jamboard may I use? Jamboard. Make sure I'm not make no mistake. That's 20 again, right? Make sure you're not
Yes,
guys.
sir.
Yes,
And
sir.
then
And then a 10. Then two 10s.
Then two $10.
Thank you. We just want to make sure, guys.
Then a 5.
All right. And then a $5. Let's do this.
$5.
All right. And then what again? 20.
A 20.
$20.
All right. Thank you.
And then the last one is $5.
The last one is a $5. All right. Good. Hold on, guys. Let me fix back that. All right. There it is. So when you go in there now, you would have seen this just like this, pretty and clean. And then now, so the question is saying down here, which chart correctly represent the information? So we want to know which one of the chart correctly represent the information. The numbers you're looking at, I would help you. This is 02468, 02468. Can everybody see that?
Yeah, I can see, but
Yeah.
I'm going to help us to understand now. Let us know how many $5, how many this we have. That's what we need to have. So let us just take out a slide here, a spot here. We need to know how many $5 we have.
Sir, 6.
All right,
6.
$5. And how many $10 we have?
5.
5.
5.
How many $20 we have? So
4.
4. So as long as you can, yes. So the thing is, as long as you're able to tell this, then
Sir, it's $7 not 6.
$7 confirm with me. $7 is correct. 1, 2, 3, 4, 5, 6, 7. I agree. 1, 2, 3, 4, 20, and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, $10.
Yes, sir.
Sir, $7 $5.
$5. That's it. Now let's go now. We're going to try to match this on our charts. Let's go. Let me use a marker to help us as we go across. Now we're looking at $5. So you're looking for $5 to be between 6 and 8, because based on how they're doing this, your $5 should come between 6 and 8. If you look here, this $5 is at 6, so it is incorrect. So this chart is incorrect because the $5 is already wrong. All right, because we said it's $5 we have up here. So this $5 is also wrong because it is between 2 and 4. So this $5 is 3. That means this chart is wrong. Everybody can see the point we're making?
Sir.
And even this one also
Yes,
is wrong. It's also
So
wrong.
number
because
2 is correct.
$5 is wrong. This one, the $5 is at 7. Can you see that? It's between.
Yes, sir.
Yeah,
Right.
Yes,
And this
sir.
one, the $20 is between 4 and 6, which is 5. So you could see that the $20 would be right there. And you can see that there are $4 $20, $4 $20, should say, and the $10 would have been 5 between here. So this one would be the correct one, based on what we have. Good?
Yes, sir.
Sir.
Yes, sir.
All right, so the question is, which chart is
Yes,
correct?
sir.
So the answer is chart 2. Everybody say chart 2 is correct?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
All right, good. All right, let's go to another chart now. It says, use a diagram below to answer the questions. Now, this one now is a little bit tricky. We have to use the diagram below to answer the question. It says, how many boxes did Mr. Williams deliver? So there are the boxes, and this is sometimes where the trick is. A lot of people tend to want to just count these like 1, 2, 3, 4, 5, 6, 7. People are counting the obvious, and it's not 7. If you count the obvious, you're in problem. You know that?
Yes, sir.
All right. So what you're going to have to do, you're going to have to be thinking, you know, you're going to have to
Sir,
think. Yeah?
sir, 9.
There's
let's check.
11.
Let's check to see. Definitely underground, underground. Underground, you know that you will actually have 1, 2, 3, 4, 5. How many do you think is underground? Is 6 underground, you know?
6.
Yes, sir.
All right, very good, very good. 6, I hear 6. So it's 6 underground. And then now, on top of that 6, we have 1, 2, 3, 4, you know? You know, it's 4 you have on top of that. So we have, so firstly, so we have 6 on the ground. All right, so I'm just going to stack it on top of another. And then on top of that 6, we have 4. All right, then we have 4 on the 6.
Wait, sir.
Yeah?
The highest one shouldn't there be one underneath that?
There.
The one at the very top.
Yes, that's how you count the 4. Because you're seeing 3, but 1 is underneath it. Because the only way you could put it on top, it has to be standing on something else. Not true?
Sir.
Yes, sir.
So
Yes,
that
sir.
is, yeah, man. So that is the trick. They have a trick people. Because a lot of people get tricked, and then we have a 1 on top. So this is what is going on. We have 6 on the ground, then we have 4 on that 6, and then we have 1 on that, on the top.
Sir, I don't get it.
Sir, how is 6 on the ground?
Always 6 on the ground. All right, watch this. Watch this.
There's 3 behind the one facing out to the front.
All right, watch this. All right, watch this. Very good, very good, very good. Who is that? Turner? Who's talking?
Yes, sir.
Okay, Turner. Turner is correct. Because let's think now, Mighty, under this one right here, don't you think that there is something underneath it for it to stand on there?
Sir.
All right. So that is an extra one. And then go furthermore. This one that is at the top, it is on one that is actually on another one that is on the ground. So on the ground, I think the shape on the ground is like this. Let me see if I could. All right, let me see if I could show you. I'll try to show you what we have. This is ugly now, all right? But that is what is on the ground. Mighty, you see what I'm saying?
Yes, sir.
On the ground, you will have it like that. So this is what is on the ground. 1, 2, 3, 4, 5, 6. And then they stack up one pan, they stack up, and then this is the other 4 that they stack things on. Can you see this? The second layer will be 4 more right here. That is why we saw these 2 exposed. These 2 here. Let me rub it off. I'm trying to explain. I'm not sure if you. These 2, this one and this one, these were here. And the other 4, these other 4, we put the second layer and call it layer 4. See it here? And then lastly was this one. So this actually have 3 layers going up top to the last one, this one in the corner here. So we have 6 on the ground, then we pack 4 here. All right, let me see if I can help you with the coloring. Just going to try. On the ground, we have all green. That's what we have on the ground. And then the second layer, it was all blue here. That's what you're seeing. Second layer is that only. That 4. And then the last layer, you're seeing this. You understand what I mean, guys? So it's like they're packing on top of. So it's a 6, then 4, then 1. Is that clearer? So he actually delivered.
Yes, sir.
He actually delivered 11 boxes. A lot of people will pick 7 and 10 and 9. But it's not what you're seeing. It's what you're seeing plus the ones that you can't see because it's already been packed on. Everybody get the point?
Yes, sir.
All right.
Yes, sir.
All right.
Yes,
So,
sir.
guys, do you see what's going on though? These are the type of questions you're going to get.
Yes.
So you have to be
Yes, sir.
you have to be thinking, and that is why I'm going through these, because I want us to really understand what it is we are up against and what is it we're dealing with. All right. All right, let's go. Yeah, let's go again for the next one. Number 29. Number 29 says, at last year's Boys and Girls Championship, it was estimated that half the national stadium seating capacity of 35,000 patrons were cheering for KC. Which of the following could not be the actual number of people cheering for KC? Now you have to think. You hear what they said? We have 35,000 seats. All right, so I'm going to put possible seats. That means we're saying that on a given day, when the stadium is actually filled, it's 35,000 people that can hold there. They are suggesting that half. So they're saying, all right, let's read again. Read what they're saying. At the last year Boys and Girls Championship, it was estimated that half the national stadium seating capacity of this patrons were cheering for KC. All right? Which of the following could not be? Now, which of the following could not be?
22,500.
Very good. 22,500 could not be. Because every else thing could be. It could be this. Because if this were, because you just want to know that when you multiply this by 2, it does not pass. Because you know that if a stadium can hold 35,000, then everybody may not come on the day. Probably 34,000 come, probably 33,000 come. So at the same time, we are suggesting that if I can multiply these numbers by 2, and when I do it, it is less than or equal to this, it's possible. But definitely, if we multiply 22,000 by 2, it reaches 45,000, which is incorrect because this can't be half because the stadium can't hold more than 35. So yes, the number could not be as big as that for half. Everybody can see the point?
Yes, sir.
Yes.
Now, let me ask the other question. If I ask you for this same minute, I'm just asking something that's not here. If I'm asking you a question like this and I say, what is the maximum number of persons that could be cheering for KC? What was the maximum number that is possible? Talking about possibility. What could have been the maximum number that is cheering for KC?
$16,975.
Why? Why?
Sir, because when you multiply 17,500, you get up to 35,000.
But isn't 35,000 the seating capacity?
Yes, sir, but they said half of them are cheering for KC, so it would have to be something that is around half.
Can I say this to you?
Yes, sir.
What if the stadium was filled on that day? How many persons would be seating in there, would be there? 35, right?
Yes, sir.
And then half of 35 is 17,500, right?
Yes, sir.
So when I use the term and said the maximum, I am saying that imagine that the stadium was full. The idea still remains that half of them will be changed for KC. So you'd have to say, okay, full is 35,000. Half of that is 17,500, don't it?
Yes,
Yes.
sir.
So if the question was like that, then the answer would have been 17,500. Because I'm not just saying let us work these out. Because it's not like say you're going to go in there and see back a question like this, but we want to be able to have ideas in our mind, you know, and we could work out stuff, right?
Yes, sir.
All right, very good. All right, let us see another question. Let me see what's here. Oh, number 30. Hold on, let me see if number 30 is there. Oh, it is. All right, I'm going to put it back when I'm done because I can move this around. Let's look at number 30 a little bit and then I put it back. All right.
Yes, sir.
All right, I could have put this up here in the beginning. I just didn't realize that it was way down there. All right, let me put it there and then move back the things. All right, this could stay there, and I could pick back over the answer. I could put these up. Let me just put these up, and this could stay here. I'm going to about this. And we'll just pick the right answer and let this stay because I didn't realize that the other question fell down. So this answer was 11. And I highlighted that for memory. And this answer right now was this, could not be that. And then we're at this. Good? We're good now. So the question says, which is best? Which is the best estimate for the length of a football field? Of a football, not a football field, a football. All right. You know what 2 centimeters is? Let me show you what 2 centimeters is. 2 centimeters is from right here to right here in reality. This is 2 centimeters in reality. Could this be the size of a ball in reality? No. So
No,
this
sir, 5 inches.
5 inches.
That would be more like it.
5 inches, mighty, is just, all right, let us say your finger, right? Say, if you look at your middle finger right now, if you should take 2 more joints and add to that, that's about 5 inches. You think a ball is that small? So 5 inches is not. It's like 1 foot. 1 foot is 12 inches. Here, one foot is approximately 12 inches. And if you think about 12 inches, a ball is about 12 inches. Yeah, man. So 12 inches. So 1 foot is about 12 inches. So this would have been the answer for the size of a ball. 5 inches is too small, Mighty, because if you look at it, 5 inches is like your hand middle. Like, you understand what I mean, Mighty?
Yes, sir. I am.
And if you notice, look at the type of questions that they're asking, though. So it's called mental ability, right? All right, not bad. So 1 foot is like the size of a ball. And remember that 1 foot is 12 inches. 12 inches make 1 foot. All right. All right, let's look at this one. Somebody's talking. All right, so this one says, let's go what this one says. So, anybody has a soft copy looking at? No?
Looking at you.
Yes,
All right, let me try to get the, because let me see if I can blow up this for you just to see that. But when you see this like this, other questions are missing. So probably when we finish, we can mark them. But look, see me blow it up then here. All right, look better now, right? So it says,
Yes, sir.
so it says here that Mr. Brown designed a piece of art by outlining equilateral triangles with wires. You know, equilateral triangles it really means what? Anybody can quickly just state what they know or what they have heard already?
All the sides are
All
equal.
the sides are equal.
Exactly. So all the sides are equal. So it means then, you know, that 2, oh, where my work goes? Anybody saw where my work went? Hold on. Ah, 2. I'm just showing you what they are saying in a 2, because this is mathematics, you know. So the moment you just said to me, all the sides are equal, I'm just doing it for you quickly so that you can, you know, see what's going on. So you have a better understanding about what it is that you are required to do. All right. See there? I think I have one more leave, right? Is that all? Now let's look at it. Is that all? Basically, that's all, right? Everybody?
Yes, sir.
All the sides. Yes. All right. Very good. So the question is, how much wire did Mr. Brown use? We can easily add up this. So we could, so basically, you know, we're like you're saying 3, so you just count up all of these extra things. You can count up you never had to put the 2s on it. I'm just doing it for the class. But if you can count up these, because each of these will be the same 2. 1, 2, 3, 4, 5. So you count up all of that go around. How many you get?
22. Sir, 24.
All right, let's count again. I think it's 24. It's 24. Check the person that says 22. Oh, there's no 22 here either. You see that?
Yes, sir. So probably 24.
It is 24 because it was 12 of these lines. So you get 24 for that. Very good. All right, very good. If I minimize this though, you know that my numbers are going to be off. So how are we going to do this then? I don't think that matters. We know the answer. I'm going to pick the answers when I'm done. Make sense? When I'm done, I'm just going to minimize it to mark it. Let's go to the next question. I'm going to. All right, let's go to the next question. See, these are still here standing. Let me take them off so that we can do what we're doing. Read the other question in your mind or out loud. All right, so the next question, because I blew it up so that we can see it big and pretty. The next question says, the teacher has a class with 24 students, right? She wants to put the students into groups so that each group has the same number of students. All right. Which of the following does not, and you have to pay attention to what they're saying. Which of the following does not, all right, represent the number of students she could put into groups? Does not.
Sir, 10.
10. I agree. Because 10 is correct, Mighty. Because if we use 4, it
4 times 6 is 24.
Yeah. And 6 times this is, yeah. And the 8 will give us 3 groups. But the 10 cannot give us any equal groups for 24. Everybody agree?
Sir.
All right.
Yes, sir.
All right, good. So you would pick 10 because they want, which one can't work? That's what they asked for. Let's look on number 33. Number 33 says, when David was 6 years old, his sister was half his age. So we're thinking now, when David was 6, the sister was half his age. All right. So let us draw a quick notation here. When David equal 6, all right, his sister was what age?
3.
3.
3.
3. Very good. So when David was 6, the sister was 3. So then from here, From
Sir.
here, you can come up with a quick conclusion by saying,
Sir,
oh, how much older is David?
sir, 3 years.
All right, very good, Mighty. So you can say David is 3 years older. Will that change?
No, sir.
No, that will not change. Very good.
Sir, so the sister is 15.
Exactly, exactly. Do you know that a lot of people would have picked 9?
Sir, I was gonna say that.
Yeah, and that is why we are in class, because we want to start to think a certain way. Because when they said half, you would understand what the sister is now. And then when I said to you, if that will ever change, you would realize that no, you know, because if I was born 3 years after my brother, he's just going to be 3 years older than me all his life. I understand, but a lot of people pick 9 for this and got it wrong, but not us. All right, we know what's going on. So David is just 3 years older. So when David is 18, the sister is now 15. Is that clear for the class?
Yes,
Yes,
sir.
Yes, sir.
All right, very good. Let me minimize this and mark the answers for us. Please. Oh, Lord. Look like it now. Give me the chance to do it. All right, let me try again from this angle. If not, I'm going to have to just leave it. It's not giving me the chance to minimize it, you see? It's getting bigger, but it's not coming smaller. I'm not sure why. Well, let's leave it. Oh, why is it doing this to me, though? Let me try one more time. Not minimizing Mighty at
Yeah.
all. Huh? It's not minimizing. Let me try one more time. I want to minimize it so that I can pick the answers. It's getting bigger. It's just not going back down. I'm not sure why. All right, sorry about that. I hope, all right, but you guys will be okay though. All right, I don't know what to do. I just gonna have to leave it. All right. I have to just leave it. This one not going down at all. One more time. Did it move?
Sir.
Yeah. Never give up. See that? Never give up in life. All right. I could put these down here. I could put this down here. And then I could just mark the answers. All right? Because when you're going back over, I want you to see the answers already anyway. So we mark the answers here. For revision, we're seeing it over. And for little clues on the side, we can see these as we go on. All right? I could put these that all sides are the same length, right? Which is equal to 2 centimeters based on the question here. I could just put that here so that when you're going back over, you will see that as well. You want me to put a little notation for this one too, right here for this one here, that I'm going to just put a general thing. 24 is not divisible. So you know those by 10. So most of you know what divisible means. It cannot go into it without leaving a remainder. So that's the idea that we use. When something is divisible, it will go into it without a remainder. 10 is not divisible by the 24, and that's why it is the one that cannot work. All right, I'm going to highlight cannot here. This is a keyword, key phrase here, cannot. And because it's not divisible, that's why that's the answer. Good to go now?
Yes, sir.
All right.
Yes,
Good.
sir.
All right, very good. Remember to go, all right. So basically 33, I think something is missing, you know. One of my questions, some of my questions are missing, guys. See, I had
33.
34, 30, yeah, 34 to 40. Hold on. These are other questions. Let me see if I can find, man. Oh man, they're gone. It's okay. All right. The other ones are missing. Not true. You see it?
Yes, sir.
Yeah. I think it's two. I could go and look for. All right. We don't have to look for them. You want me to go and look for them, or want us to continue with some more stuff?
Sir, just continue.
Continue.
Sir,
Yes.
just continue.
All right. Good. All right. Let's look at this now. This paper is the 2019 mental ability paper. This one that you're looking at. It came 2019. All right. So let us now see. Okay, you can see that it's almost similar to, like the one before. Look at it. Let's start with a sequence question. So you could see that here we have 6, then 12, then 20, 26, 34, 40, and so on and so forth. What is going on here? All right. What is going on here? Let us see if we can find a pattern. We have 6, and then we added 6. Then we're seeing what you add 6, then you add 8. And then you add what? 6 again. Then you add 8. Then you add 6 again. So can you see? Writing down what you have is always important. You agree that they added.
Yes.
Yeah, can you see the pattern? They added 6,
Yes, sir.
then 8, then
6, then 8.
yeah, then 8, then 6. So we're seeing that idea. They added 6, then 8, then 6, then 8, then 6. Then naturally, we're expecting that we're going to be adding 8 this time. So,
Sir, so B.
yes. I'm listening. Go ahead.
Sir, would the answer be B?
All right, sir. Yes, it's B. 8 plus 40 equal 48. So I want you guys to just always look through your pattern, man. Always. So we're going to circle the correct answer now. The answer is 48. So you always have to look to see what's going on as you go through. All right. Added 6, then 8, then 6, then 8, and it goes on like that forever. All right. Good. All right. Let's check this other one here. And this one says the numbers in each diagram below follow the same rule. All right. So they're saying that, hey, the numbers they're looking on here, they're following a certain rule. All right. So it says use the first 3 diagrams to help you find the missing. So we're going to be studying these 3 this time. 3. I want somebody now to look quickly and tell what it is that you're noticing. All right. Can you see the numbers?
Sir, yeah, sir. 2 times 5 is 10.
All right, Mighty. Very good. So you're saying that 5 times the 2 there give you the 10. You're seeing that. Let me turn it on the side like that for you. You're saying for that one, you're seeing that right here. 5 twos and it gives us the 10. Exactly.
Sir, could the question mark be 7?
All right. Well, it's not 7. But look, there's no 7 there, Mighty. Come on. Why would you pick an answer that is not there? So this one, though, is 7 times 4, and you get 28. Everybody agree?
Yes, sir.
All right. And this one here, that's your 9 times 8, and that is 72. Everybody agree with that too?
Yes, sir.
So when you're looking at, yes, go ahead, speak.
So I was saying that I found the answer.
Very good. What did you do first? Tell me what you did rather than just give me the answer. What did you do?
So I found out how many times 11 could go into 132.
Exactly. Exactly. So for this one, there are many ways you could do it depending on if you well know your timetable. Because if you well know your timetable, you could just be thinking that, okay, what times 11 that gives me 132? And you got your answer to be
12.
Exactly. So it's 132, and you want to divide that. You divide that by 11, and your answer is 12. 132 divided by 11, and your answer is 12 for this one. Let me just turn it a little bit here for us to see what's going on. All right. So we would have picked that. And then what was the principle here? You realize that you sort of work backwards as well again. Working backwards. Because you saw that everything multiplied to give you a certain thing. And then you're saying, but okay, what's going on here? I mean, I can divide this because I really need to divide to see what's going on there, right? So we were working backwards for this one. What times 100 and what times 11 that gives me 132? Well, I could just simply divide 132 by 11 and 12 is the answer. Excellent work. That's it? Good. Can we move on to the next slide? All right, let's go.
Yes, sir.
All right, good. So the next question says, oh, somebody was sending me a note. Okay. Somebody was sending. Johnny, I just saw the message you were sending. You hear? Sometimes I don't see them. All right, let's go. This question says, all right, let me blow up this question. We should be able to blow up this. There's only one on the screen. So if we blow this up, nothing is wrong. All right, there it is. So this one says here that a pattern is shown below. All right. Oh, all right. Do you agree that this one looks like the other past paper question?
Yes, sir.
Yeah. Looks like the other past paper question. And then look at this clue now. Do you notice that? Look at this that you got, and then look what is going on right there. So it's actually at 6/7 right now. So if right now I'll be thinking that 6/7.
Sir, and 7 into 7 go 1.
Ah.
And 1 into 14 goes.
And the 7 into the 14, you mean?
Yeah.
Yeah.
Goes 2.
2 times mighty. Very good. So you could see what they were doing here. That is how they got that 1. Yeah. 1. And then now we're going to divide this by 7. And our answer will be 2. So you could see here, based on the pattern, you look. And then, it's always, I would always say to you, just look at what they're doing, because they were the one that did this for us first, right? They were the one that did that for us. So I could see that my 6 was divided by 7 by them. I would try that first to see if it worked. Then I would say, you know what? I'm going to divide 7 by 7, like what Mighty said, and see if I get 1. Oh, I get 1. That means everything is being divided by 7. So our conclusion here for practice or for revision when we're ready, all right? Our conclusion is that everything was divided by 7. So this is the little note that we need to bring to our memory whenever we're going back to it. Everything was divided by 7. You could see the pattern. Is that clear enough, class?
Yes, sir.
All right, very good. All right, let's go to the 9th slide. All right. This one says, it seems as if this is somebody's name. I think they said Andrew represented the shapes below on a chart. All right. So we're talking about numbers. Isn't this one just like the 10 cent, 20 cent again? Can you see what's going on with their exam?
Yes, sir.
Yes, sir.
Yeah, so this one is just like the 10 cent, 20 cent and so. But guess what? They're using shapes. So what we want to do now is so we have triangle. What we have triangle, circle, and square. All right, let me see if I have these here. Let me see if I have them. I have a triangle. All right, let's put it down. All right, I have a circle. All right, let's put it down. I have a square. I have everything here. I have a square. Let's put it down. And then what we want to do now is to balance back to see how many of each we have. All right, so let us do that quickly. For the triangle, let's count up 1, 2, 3 triangles. Everybody agree? We have 3
Yes, sir.
triangles.
Yes, sir.
Right, very good. Let's put that beside it. For the circle, count up for me, guys. Somebody count for me. How many circles do
We
we
have
2.
1, 2. We
have?
have
2 circles.
Yes,
sir.
sir.
All right.
Yes, sir.
And then for the square, how many?
1, 2, 3, 4,
Three.
5, 5.
5.
5?
Yes,
Yes,
sir.
sir.
Very good. So now the thing is, the moment we have the numbers, right, guys? The moment we have the numbers, all we have to do is just to relax. And then now look back at the scale that they have. Look back at how they number their axis, sir. So they are numbering the things 0, 2, 4. Everybody could see 0, 2, 4, 6, 0, 2, 4, 6.
Yes,
All
sir.
right, very good. So now we're going to look to see 3. 3 will be between, so we're looking at the triangle. Let's just say we're looking for the triangle. 3 is going to be between the 2 and the 4. So we're
Yes,
looking
sir.
for something between the 2 and the 4. So you could see that this is wrong. You could see that this is wrong. You understand? You could see that this is also wrong. And
Number
this one,
4.
number
Yes, sir.
4. Because see, there it's between the 2 and the 4. Everybody could see that?
Yes, sir.
Yes,
So
sir.
chart number 4 is correct. The thing is, some of the times when you look at one thing, you're able to see what you want. And the fact that all of these are incorrect, I don't need to double check circle and I don't need to double check the square, because guess what? If this is wrong for one thing, it's wrong overall already. You see the point we're making?
Yes, sir.
Yeah, man. So this would have been the correct one. And then here it is, chart number 4. Very good. Very good. Very good. So if you notice, there are some similarities, they are setting the questions though, because we saw something like this in another way. All right. Another point I want to bring out for us here is when you're looking for your answers, be aware that they will label their axis. All right, you will see certain numbers, but you should have a good judgment of other numbers. Because if I see 0 and I see 2, I know that 1 is halfway between that. If I see 2 and I see 4, I know that 3 is halfway between that. If I see 4 and I see 6, I know 7 is halfway between that. Can you guys always look out for stuff
Sir,
like
you
those?
mean 5.
Yes, Almighty. Thank you very much. 5 is halfway between that. Thank you for that. At least you're listening. But I want you guys to always look out for stuff like that so that you can easily move through. Let's jump to the next one. Right. So we're gonna have to read this one now. So this one, let me see if I could blow this one up for us. All right, hold on, guys. Since it's only one thing on it, let me see if I can get it a little bigger. Oh, I can't even find that. Oh, let me see. All right, I can't get it too big anyway. Can't work. It's okay. I'm gonna have to leave it because I won't be able to see the answer. All right, are you guys able to read the ones that you have? Yeah, I think we can read this. It says the survey. All right, let's go. Ready? All right.
Sir, I did this in class Mondays.
Well,
Population and sample.
all right, no problem, sir. Very good. Let us see what's going on. It says a survey was done, right? And 40, make note of this, 40 students were asked about their favorite sports. 40. The following information was gathered. No more than 10 chose volleyball. And when they said no more than 10, you know what that means? No more than 10.
Yes, sir. Only 10 of them chose it.
Sir, it could
10
be
10 of them chose
are
it.
could be 10 or below.
very good. So we could say 10 or less to suit that. 10 or less is a good way to put it. Good?
Sir.
All right, very good. So we want to draw those conclusions as we go forward. 10 or less. All right, let's go for the next one now. The next one says, more students chose football as their favorite sport than the number of students who chose volleyball. So more chose football than volleyball. Then what can you say about this? About football? Football has to be more than what?
10.
Yeah, these are just some little
More than
conclusions.
10.
It's more than 10. We know that. It's more than 10. Very good. Football is more than 10. And more than 10 could go all the way up to anything, but we know that it is bigger. So basically, we're saying that football is bigger than volleyball in terms of those who chose.
Sir, it can't go past 40.
All right, good, good. And I want you to conclude that the football piece must be always bigger than the volleyball piece. Good?
Yes, sir.
All right.
Yes,
very
sir.
good. All right. Let's go to the last piece of clue now. More students chose track and field as their favorite sport than football and volleyball together. You see that? So that means when you add up the football and the volleyball together, it is less than track and field. All right.
Sir, number 3.
So let us observe those now. Let's observe those now. So track and field is the biggest thing right now, right? So any one of them with track and field small is wrong. This is wrong because look at our track and field. Track and field is the biggest thing. This is wrong because our track and field is the biggest thing. So you can see over time you can quickly start conclude that, hey, this
Sir,
cannot.
small is not biggest.
Yeah. So those can't be the answer. Now let us look at number 3 and number 4 now. All right. When you look at let's go to number 4 because it is incorrect. Remember we said that football is bigger than volleyball. Yeah. So when you look at the football here, you say, no, that cannot be because the football cannot be smaller than the volleyball based on the information that we got. Is that clear?
Yes, sir.
So chart
Sir.
B would be correct and we go for it and said, here is the answer. And this is how we reason out our things as we go. Is everybody okay with that? Is there anybody that is?
Sir.
We're good with it?
Yes, sir.
Isha, not
Yes,
hearing
sir.
much from you. Isha, you're not talking.
Yes, sir.
You're good. All right. Jude, everything good?
Yes, sir.
All right. Good. All right, let's go to another slide. All right. This one now. You're all right. All right. Anybody, you remember that we did one like this on the other past paper?
Yes, sir.
So basically, kind of telling you what to look for in your exam. All right, let's go. We're saying that we have 1, 2, 3. This is 8. So 6 out of 8 here. Anybody do you know that if you represent 6 out of 8, right? 6 out of 8. Hold on. Somebody calling me. Let me just respond and tell them that I'm in class. What are you doing? I'm in a session until 11 o'clock. I'm in a session until 11 o'clock. Can I call you 11? I'll call you 11 o'clock. That good? All right, good. All right, guys. Everybody agree. Can we agree that we're looking at 3 quarters here?
Yes, sir.
Yes, sir. Yes, sir.
Yeah, man, it's 3/4. 3/4. All right. I think I put the wrong number here. Yeah, man, we're looking at 3/4 right there, right now. 3/4, right? That's what we're looking at right here for this. All right, so this is 3/4. And you can see that they did represent it here. They're telling you that, hey, see here, this is 3/4. All right, this is 3/4 because if I had done that and if I had done that, you see that it is 3/4 basically. Now this though, what would you say this is? Watch this. If I pull this line go down like this.
Sir, 1/4.
It is 1/4, Mighty. Very good. Everybody agree that it's 1/4? Can you see that?
Yes, sir.
All right. What you can do though is to do regular maths. Like, let me just go back here. This one was 6 out of 8. And when you use if you use 3 to cancel on this, you would have gotten 3 into, not 3, 2 into this goes 3 times, and 2 into that goes 4 times. So we could see that if we cancel down. This now, you're getting 2 out of the 8. And 2 into itself 1 time and 2 into 8 4 times. So you could see that this is 1/4. Which one of these would represent 1/4?
Sir, C.
C would represent 1/4.
C.
Very good. So those are some of the stuff that you can do at times, to go through and to get your answers out. All right, very good. Let's just look at question 27. It says David is twice. Hold on, we're gonna have to put down some notation now. Ready for the notations? David is twice as old as Rachel. All right, so we're saying that, can I call David D? D, I'm going to call David D, all right?
Yes, sir.
So David is 2, let's use the word twice, and twice means 2 times, right? David is twice Rachel, and I'm going to call it Rachel R. So David is twice as old as Rachel. So D is twice as old, twice for Rachel, right? All right, let's go again. Next one now says that Peter is 5 years older than David. All right. Now we're seeing Peter is older than David, you know. All right. So we're talking about P for Peter is 5 years older than D. All right. All right. So okay. All right. And then the next one now is that David and Kim is 3 years younger than Rock. Let's go again. Than David. Oh, Kim. Kim is 3 years older than Rock. All right. So Kim. Oh. Where did my thing go? Come back. Anybody see what I wrote just now? Oh. All right, good.
And Kim is 3 years younger than Raquel.
Very good. K, 3 years younger than Raquel is important. All right, so we could now put it together because as you can see, they want the age in order from youngest to oldest. Now, based on this information, who is the youngest?
Sir, Kim.
Kim is the youngest. Everybody agree?
Kim.
Yes, sir.
K is our youngest.
Yes, sir.
And then now.
Sir, could it be D?
All right, so K is the youngest, and then Raquel and David. Yes. Yes, this is it. This is it. This is it. That's the answer. Because we're talking about Kim, because Raquel, because David is older than Raquel, and then Peter older than David. So it's Kim, then we have Raquel, then we have David, then we have Peter being the eldest of them all. Very good. Everybody agree with this?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So all you have to do is just relax and look at these questions. Don't stress anything. All right. I think I can get this. No, probably not, because it's kind of slantish. Let me see if I can get it a little bigger. Just a little bit bigger. Put it back like that. Can get it a little bit more. That would work because it copy lean. All right, let's go for it. It says a box of 12 light bulbs fell. Some are broken. Which of the following numbers could not be the number of unbroken light bulbs? You know what I said? This says a box of 12. How many bulbs were in there?
12.
12.
12. How many bulbs can be broken? How many can be broken?
12.
12 or less. Not true.
Yes, sir.
So then
Yes,
when
sir.
they're asking which one of these numbers cannot be unbroken bulbs, like definitely cannot
14.
be more than,
14.
yeah,
It can't be 14
14.
can never be
because there's
14.
12.
Yes, because we only have 12. So how can we have 14 broken balls out of 12? Very good. So 14 cannot be. Which question does this one remind you of from the last past paper?
I think it was 32.
The one with the stadium.
Yes, sir.
That
Yeah,
one.
with Casey and son.
Yeah, so you realize it's like they repeated the questions on the style.
Yeah, I think it's question
They
32.
just changed the questions a little bit.
A little bit. So this one reminds us of the KC state.
Yeah, but the way you work it out, it's the same thing.
The same idea. Yeah, it's the same idea you're coming up with. And the thinking process. All right, let's go to the next one. The numbers 1 to 10 through 10 are placed in a bag. All right. Paul picked a number from a bag and then performs an operation stated column A and column B. And all right, good, good, good. All right, let's read. All right, so he's going to pick a number from the bag. And they said that to perform the operation stated under column A and column B on the number. Column A, the number multiplied by itself and added, and then 1 added. Column B, double the number and then subtract 1. All right. From the information given, which statement is correct? The number in column A is greater than the number in column B. The number in column B is greater. The number in column A is equal. The answer cannot be determined by the information. All right, these are small numbers that you can try with, right? Agree?
Yes, sir.
Yes, sir.
Like in a case like this is why they give you these numbers from 1 to 10, because the numbers are quick. You can try with them quickly. If you get what I'm saying. So it's like you have, let me tell you what I'm saying. Don't guess the answers because you can easily find out the truth. So never give up on your answers by just saying, okay, guess that, blah, blah, blah. Sometimes you're able to figure out some stuff, but I am saying that you actually can easily figure out based on the numbers, right? So let us assume that we pick a number and it's number 10. We're going to quickly work out number 10 with A and B and see which one bigger. We're going to try a couple numbers and then see if we could draw conclusions. You get the point I'm trying to make? Pick some numbers and then we're going to try the conclusion. So let us say we pick 10.
I've done some of these before.
Very good. Very good. So if we pick number 10, let us say we pick number 10, right? The number is multiplied by itself, that is it, right?
Yes, sir.
So, and then you add 1. So 10 times 10?
100.
So this becomes 101. 101. And then now under column B, if it was number 10, again, double the number.
21.
19.
19.
All right, so column A is leading for 10. Try another number. And then after that, you can realize something. Let us try, go to a small number now. Let's try number 1. 1 times 1? 1 times 1 is 1.
Yes.
Yeah, man, and then you take 1 from it, you get 0, right?
Yes, sir.
Over this side now, when you double 1, you get 2, right?
Yes, sir.
And when you add 1 to it, you get 3, right? And then you subtract 1, you get 1, right?
Yes, sir.
Oh, hold on. I think I made a mistake with the first one. Note it. Hold on. For this one, when we pick number 1, hold on. You're supposed to add 1 to it. So 1 time, hold on. Let us not make an error. 1 times 1 is 1 plus 1 give you 2. Was this what you wanted to say to me, Mighty?
Yes, sir.
That's my error. All right. I subtracted. I didn't even realize this add. All right, good. So it's 2 for this one here. And then over here now, when we double 1, we get 2. And then you're supposed to subtract 1. You go back down to 1 again. Let's try one more number. So column A is leading with the big number and the small number. Let's try a number in the middle, like number 5. 5, 5, 25. 25 plus 1, 26, right? Then now, if we double 5, we get 10. And then you take 1 from 10, you get 9. Can you now conclude that column A is working out to a bigger number every time?
Yes, sir.
Yes, I would conclude that column A is bigger. each time. Each time it is bigger. So we can draw a conclusion, you know, after trying a few numbers. So, and it didn't take long, you could do it quickly. So column A is greater than column B. So the answer is A. Is this it? The number in column A is greater than the number in column B. Everybody agree to that?
Yes. Yes, sir.
Yes,
I agree. Turn
Yes,
off.
sir.
All right, good. So the point we're getting at is that sometimes all you have to do is just to work out the thing. Don't guess it. And don't try to be thinking it like some people, without working out anything, some people just try to think of. Don't do that, man. They told us that the numbers are from 1 to 10. Pick some numbers and try them under the columns, mighty. And then you will see your result. And then you can make your conclusion. And in that way, you will get your exact answer. All right? Very good. And let's jump to the next one now. All right. This one is this one, you have to think about what you're doing here. Let me see if I can get this a little bigger for you. Hold on. Oh, will I get it a little bigger? Might be. Oh no. I don't have the space up top. Okay, I see what's going on. All right. All right, let's work with what we have. All right. All right, can we go now? It says the diagram below shows two rectangular boxes with a strip ribbon wrapped around each. All right, with a strip ribbon wrapped around each. So we have that. Now, watch this here. Now, we want to figure out what's going to happen. Now, the numbers, can you see the numbers? Or you want me to put, can you see that this is 8? This distance is 8, this is 4, and then this is 6. Can we see that?
Yes, sir.
Yes, sir.
All right, good.
Yes, sir.
Baby.
All right. In one case, we're wrapping it going this way, right?
Sir, I did that one as well.
Yeah, and in another way, we're wrapping it going the other way like that, right? So then let's put together the measurement in the two sections. Let me put the measurements here that we're going to be doing. So I want us to think. If you're going to wrap it like this, you're going to be wrapping this distance, you know that this distance is 6, right?
Yes, sir.
So you're gonna get 6. You're gonna get 6 plus 6 on the other side. 6 and 6 on the other side. Agree? You'll get 6 and 6 on the other side coming down when you're ready for the other side over here. On the back part of that. You're also gonna get 4 at the top and 4 at the bottom. Everybody agree?
Yes.
So if I should put it in order though, because maybe people want to see it in order, let me just put it in order. If I put it in order, you'll have 6 plus 4, then 6 plus 4 again, and you end up with 20. Agree?
Yes, sir.
I want everybody to talk to me, man. Agree with that or not?
Yes, sir.
Because we're going to wrap it this way. See there? Don't watch this 8, because we're going up with the wrapping, and this distance is 6. So we're going 6 up and then 4, and then 6 come down and 4. All right, very good. For the next one now, for the next one, we're not doing that, right? For the next one, we're not doing that at all. For the next one, we're wrapping 8, then 4, then 8, then 4. Everybody agree that this distance is 8, and then this is 4. 8 plus 4 plus 8 plus 4 this time. Everybody can say that? We get 24.
Sir.
Yes, sir.
Yeah, so with this one, we would have gotten 24. With this one, would have gotten 20. The question is, the ribbon is wrapped vertically around this, and we could see that, and it's wrapped horizontally here. So let's draw some conclusion. Given that both boxes, right, have the same dimension, we're seeing that the ribbon on A is longer than ribbon on B. This is wrong. The ribbon on B is longer than the ribbon on A. I want to agree to this right now. The ribbon on B is longer than the ribbon on A. Agree or not?
Agree.
And I don't need, you see, when I find this agreement, I'm not going to read the rest, because the rest will be incorrect. Because if you read it, it says the ribbon on both are equal. It's incorrect. The answer cannot be determined. No, we can determine the answer. So you could see that whenever you find your answer, you know that your answer is good. You don't need to be wasting time to reading other responses when you know you have picked up the right answer. All right. All right. Let's go to the next slide, right? All right, so for the next slide, it says the diagram below shows a parallelogram, PQRS. Diagram below shows a parallelogram, PQRS. Well, all right. PQRS, so let us walk it. P to Q to R, S. PQRS, all right, very good. So the question is, which of the following represents the greatest length? Well, let's see. They're putting some stuff together. So they didn't give us any dimension really, but we're going to try to find out what's going on. We know that this one is the longest right now. We know that. You know that this one is the longest, right?
Yes,
that went
sir.
across here. This one is the second longest, and this is the shortest. So, and then there is a thing about parallelogram that I need to tell you, that this distance is the same as that distance, all right?
Yes, sir.
And this distance is the same as that distance. This distance is the longest and it is different. I'm going to put 3 strokes on it. So my 1 stroke is the shortest, 2 stroke is the second, and then 3 strokes is the longest. So let us see. We're going to put together the ideas and see if we could come up with it. All right, so PQ plus PS. They said PQ, where is PQ? PQ plus PS. Well, I'm not going to decide it. Because what I'm looking for, if I get PS and QS, or QR and QS, I'm good. PQ again and SR. PQ is this, you know. PQ is this short side with SR. Not really.
Sir, SR is the same.
Yeah.
Going up.
Yeah. SR. All right. QR plus PS. QR plus PS. All right. So this is actually 2 are the second longest, right? So this is not bad. QR and PS. But I want something with QS in it. This is it. So they said no. QS, which is the longest. Oh, and they're adding that to SR. Nah, I wouldn't take that.
Sir, C.
Yeah, I would rather take C, QR, and the PS. I'll go with that. Everybody agree? I'll go with the
Yes,
two.
sir.
Yeah, man, I'll go with these. All right. So this one would have to pick this one for the answer. Very good. Very good reasoning, Mighty. All right, we have more questions coming here. Okay, I think I could push this one up a little bit. And then pull it down back. All right, that could work. That's a little bigger. All right, let's go for this. So this one says, K estimated the number of people in the stadium. You see what next question here? To be 32. So 32 is the estimate, right? So she estimated the number of people in the stadium to be 32. Which of the following number could not be the actual number of the people in the stadium? You hear that? When she said estimate, do you know that they mean round off right now too?
Yes, sir.
All right. So,
Sir,
all right.
D.
So when we're talking about round off, if you round off, no man, the answer is actually, the answer, there are 2 answers here. The answer is actually A. If you round off this, you will go up. If you round off this one, you
Sir,
will go up.
sir, I thought he said which one could not be.
Oh, what did they say there? Well, let's just read it again. Which of the
It could
following
not be the
numbers
actual number.
could not be. Very good. Oh, that's what. Oh, okay. So which one did you suggest just now?
Sir, D.
Oh,
'Cause
D.
that's the highest.
Okay. Oh, I thought you said D2. You know. Yeah, man. This one. This is like 33,000 right now. So it could not be this. Because they said could not. So it definitely could not be this big one here. This is like 33,000. Everybody agree? All right. No, all of these other three answers could be, because if they said to the nearest 1,000, then all of these would be 32,000. You know that? All of these to the nearest 1,000 is 32. This is the only one to the nearest 1,000 that will go to 33. So it is the odd one. All right, good. So this is the answer right there. All right, let's go to the next one. You want me to put a little notation here? And let's try to put some little notes, when we can, so you can read over. So A, B, and C, if rounded to the nearest 1,000, is 32,000, but D would be 33. Make sense? All right.
Yes,
Yes.
sir.
All right, good. All right, let's go to the next one now. I think this says this. I can't even see this good. Is this Dennis or whatever? Let's work with Dennis. This part never printed good, but this said whoever that is, Dennis, is numbering the page of a book. All right. Page 1 is on the right hand page. Page 2 is on the left. Page 3 and faces page 3. And let me read it over. Page 1 is a right-hand page. Okay. Page 2, a left-hand page, and faces page 3. Okay, I get the point. Which two pages will face each other? All right. So
We did that one as well.
not hearing you. Go ahead.
I'm saying I did that one as well.
Okay, cool. All right, good. All right, so what we want to do though is to understand a quick thing here. So you can just quickly, you can mimic the idea. So this is saying that page 1 is a right-hand page. So it's on the right side. All right. So page 1 is on the right side. So even if you open up a book now and you're looking at it, you're saying, okay, if I open up a book and I look at it, page 1 is on the right. So when you open that, you're gonna have a page 2 on the left, and it's gonna face page 3 again, which is gonna be on the right. Everybody can say that?
Yes, sir.
So definitely we could conclude that on the right side, we're having the odd numbers. Page 1 is gonna be on the right. Page 3 is gonna be on the right. Page 5 is gonna be on the right. Page 6, page 7. So 1, 5. So if we want to draw a quick conclusion, I'm just saying, just for notes here, we can say pages 1, 3, 5, 7, etc. are on the right hand. Everybody agree? All those pages will be on the right hand right now. 1, 3. All right. And then 2 faces 3. And then you know that 4 faces 5. And then now 6 faces 7. Can you feel that means says the even number on the left faces the odd number on the right. Can you see that?
Yes. Wait,
Sir.
sir. I
Yes.
got my answer.
Because the answer is gonna be what?
A.
No, the even number is on the left. When you open it up, no.
Oh,
22,
Sir,
23. All of these are right hand page to left and in a not. So think about a book in your hand. Which page will face each other? These are on different page. This will be on the right page, and this is going to be the other one on the other side. Same thing here. The even number has to face the odd number. Look. All right. I don't even know how to put this. This is like, let me show you what I mean. On the first page here, on the right side, before you open it up, they said that this is number 1. You see, when you open this out, you're going to have this. Number 2 over the here, so now, and number 3 over here, so. You get the point we're making now, Mighty?
Yeah.
Imagine that the book is closed. This is number 1 on the right side. That's what they're saying. Then when you open it out, number 2 is going to be on this page, but on the other side of the page, right here. And then number 3 on the other side. So you can see that 2 faces 3. And when you move the 3 to go across, you know what's going on under that? 4 will face 5. You see the point we're making?
yes, sir.
The even number would have to start on the left to the right. So that is why 22 will face 23. And did you know that all of these others are the same ideas and they are not facing each other? All of these other ones are not facing each other. So you're talking about the even on the left has to face the odd number on the right. That's what's going on for this question. And that is why the answer is B. All right. Let's jump to this other one. Let's jump to this other one. All right. It says, Kelly wants to find out how many Jamaican $1 coin will cover the surface of her book. All right. What information is necessary for her to make this decision? So she wants to know how many $1 coins. We know that the $1 coins are circular. All right. And she wants it to cover. She wants it to cover what? The surface of her book. Well, I'm not sure what type of book she has. All right, let us say that she has a rectangular book. Let us say that she has a book that looks like this, right? Like maybe a book that looked like that. All right. All right, and then she had some coins, and the coins are circular. So I could make small circles here. I could let them be small. So she has some coins, all right? All right, and she wants to cover her book with the coins, right? Everybody can see I'm trying to create an idea here.
Yes, sir. Yes, sir.
So what's going on here? Man, hold on. Take off this one. It's the only duplicate I want. You know, why it's not giving me the duplicate? All right, I don't know what's going on. It's not giving me the duplicate now, but it's that. But basically, this is the idea I'm suggesting, that this is what they want. All right. So she has some dollar coins and she wants to do that with it. All right. What information is necessary for her to make the decision? The number of pages in the book. Let's read. Kelly wants to find out how many Jamaican $1 coin will cover the surface of her book. All right. The number of coins that fit along the edge. The thickness of the book. Is the thickness of the book necessary?
No, sir.
I don't think so either.
No,
The
sir.
total number of coins that she has. Not right now, because it's saying Kelly wants to find out how many. So at the end of the day, she needs to find out how many. So the number of coins she has, that's not troubling. She wants to find out how many. So I'll leave that one out. I'm talking about necessary information. The number of pages, well, if she's going to cover the entire book in terms of all the pages, if that's what they're saying.
Sir, it says surface, so I only think like the top.
The
or
top
the
part.
cover.
So it's kind of ambiguous. If you look, if you're a person that overthink things, then you might think that way. Understand? So maybe the number of pages does not matter. And then the number of pages in the book, and then this one says the number of coins that fit along the edge of the book. All right, the number of coins that fits along the edge of the book. What information is necessary? I'm thinking which one is best, A or B? The number of pages in the book. Maybe, as I said, Mighty, that in this case, probably that's not what they're dealing with. The number of coins that fit along the edge of the book. For me,
Yes, sir,
that's the best one. So it's like we're going to line them up, line them up, line them up. Because if I know how many fits here and there, and then how many fits there, I could tell you, like if this happened, I could say 4 by whatever. It's like a rectangle, and you said, this is a 4 by 1, 2, 3, 4. Like you say, a 4 by 5, and you say, oh, I need 20. You know what I mean? You know what I mean?
Yes, sir.
Yeah, because if you fit, guys, remember, if we fit whatever we fit along here and then fit it along here, then when you multiply, you're getting what is called area. So if you have 4 fits here and then 5 go along, then you need 20, because I'm going to have this 4 5 times go right down. If I get 5 like this, then I'm going to have the 5 4 times coming across. Make sense?
Yes, sir.
Yeah. So fitting along the edge will give us the clue, because all we're going to do is to use the idea of length times width and tell how many we need. Very good. So we can do that. So this one is a nice little reasoning one. All right, nice little reasoning. All right. Everybody there?
Yes, sir.
All right.
Yes, sir.
Good. Eve, are you there? Eve?
Yes, sir.
Okay. All right, we'll soon finish, guys. Soon finish. We only have about 5 minutes to go. Let's go. All right, so this one now says, K, estimate the number of people. Oh, this question is a repeated question? Or what? Or I am doing the. Oh, okay. Okay, let me mark the answers. I think I did mark the answers. This is the RR. Is it that I double up this by error? I double up this by error. We just did these. So let's go to the next one. All right, here's the next one. It says, can you guys read this though? Can you read this?
Yes, sir.
All right.
Yes, sir.
All right. Let's read it quickly for ourselves. I'll try to read it for the class. The tuck shop sold three different types of snack over a 3-week period. So here are the 3 different types of snacks: potato chips, banana chips, and plantain chips over a 3-week period. All right. Week 1, week 1 here, week 2 here, week 3. So this is what happened. All right, the quantity and the amount of money. All right, the table shows the quantity and that was sold and the amount of money made. Use the information in the table to answer question 35 and 36. So we want to answer question 35 and 36 using this information here. All right, 35 and 36 to answer. So what's the first question? In which week did the tuck shop made the biggest sale? The biggest sale. Which week? Which week? Now, if you're going to find out that the week goes down like this, the money that was made, we're gonna have to add up this. That's week 1. Add up this for week 2. So we have to work at it very quickly now, everybody, and add up that for week 3. Everybody can see what the point we're making, because this is the week's money. So
yes,
we could,
sir.
yes, very good. So we could take it out and answer the question. We're talking about 320 plus 240 plus, is that 300 again?
Yes, sir.
So this is what hour? This is 620, this is 860. What's the total here?
Sir, let me check.
I think it's 860. Week 1 is 860, we agree?
Yes, sir, it's 860.
Very
Yes,
good.
sir.
All right. All right, let's
Yes,
check
sir,
them now.
yes,
We're
sir.
checking them up. We're checking up this other one. What for week 2? Is that 800 at the top?
Yes, sir.
Sir, is that 900 or 8?
I think it's 8. 800 plus 280
Yes.
plus 300. All right. So that's about 1,300 and something. 1,380. Double check with me. I think it's 1,380, not true?
Yes, sir. Yes, sir.
And then for the last one now. The last one is 880 plus 300 plus 300. Oh, this is 1,480 now. This one win.
Yes, sir.
I think this one is 1,480, not true?
Yes, sir.
Yes,
All right.
sir.
The answer, we can determine the thing. So yes, we can determine the answer. And we're going to pick week 3 as the answer. So they make the most money in week 3. So what we're saying is, what I want you to take away from this question though, is the fact that all you have to do is just to add up, understand the question and add up all the things together, then to see, because we don't test in this class. Right?
Yes, sir.
All right, let's go for the next one now. It says, we have 1 minute to go. It says, which snack had its unit price change in week 3? The unit price. The unit price is when you divide. It's like you divide, you're going to divide. For example, this is going to take a lot of work because you're going to focus on week 3. This is week
Sir,
3.
Sir,
Yeah.
banana chips.
Oh, I have to work it out, you know, because I don't know by looking. But when they said unit price, they said how much for one? How much for one? Do you
Sir,
see how much for one here?
240 in week 1, 280 in week 2, and 300 in week 3.
Yeah, man, but we're saying the unit price mighty means how much for one. So you're going to have to divide. All of them, you're going to have to divide to say how much for one. All right, because we're going to run out of time. But what I want us to say is how much for one banana chips here? $40 for one here. How much for one here? You understand what I mean? Still $40 for one here. How much for one here? It's $40
Sir, you're
for one.
counting potato.
All of them is $40 for one here. Can you see that?
Yes, sir.
This one, this is $20 for one here. $20 for one here. $20 for one here. No. This is $10 for one here. You see the difference? Look, $20 times this will give you this. 20 times this, give you this. 10 times this, give you that. So this is the one, banana chips. So with banana chips, the unit price changed for one in that. But I rushed through this. I never wanted to rush through. Time is up. Maybe when we meet again next week, I make sure that we start back here and I really work it out to explain what we're saying here for the unit price. Not true?
Okay, sir.
Yes,
So we'll
sir.
start back right here. Guys, I know that some of you have other classes. Enjoy the rest of your time. I will
You too,
try
sir.
to retrieve the video here and send it to you guys. All right?
You too, sir.
Bye,
All
sir.
right. Take care.
Bye, sir.
Bye, sir.
Bye,
Bye-bye,
sir.
guys. Bye-bye. Bye-bye, everybody.